Hello friends, welcome to my channel. Let's have a look at problem 1120, maximum average subtree. In this video, we're going to share a solution based on recursion. Here we use recursion due to the fact that a binary tree is a recursive abstract data structure or data type. So first, I'll read through the statement to digest the problem requirement, and then we analyze and share the idea, and finally we look at the coding. So first, the statement. Given the root of a binary tree, return the maximum average value of a subtree of that tree. Answers within 10 to the power -5 of the actual answer will be accepted. So here a subtree of a tree is any node of that tree plus all its descendants. So this actually is also recursive. So the average value of a tree is the sum of its value divided by the number of nodes. So here are two examples. So in the second example, we have such a tree. So we have a tree with the root 0 and have a right child which is 1. So in total, so in this one, so if we consider the right subtree itself, the average is 1, which is also maximal for this specific tree. So this is the return. So for example 1, actually there are 3 trees we need to consider. First, the whole tree. So the whole tree actually has a sum 12. So if we divide the 12 by 3, so we get 4. And if you look at the left subtree, so this left subtree have a single node, and the value is 6. So the average is also 6. So similarly, another leaf node 1. So its averages to be 1. So the maximal of these 3 cases are 3. So the output is 3. So with that said, so let's look at the constraints. First, the number of nodes in the tree is in the range given by the closed interval 1 and 10 to the power 4. So overall, the tree, the whole tree itself is not null, and the number of nodes is bounded above by 10 to the power 4. So 10 to the power 4 defines the problem set's upper bound here, and the node value is not negative, and also is bounded above by 10 to the power 5. So with that said, so we are ready to look at the idea. So here again, so we are going to use a treatment similar to the previous 2 videos. So we are going to use recursion. Recursion here is natural due to the binary tree data structure or data type. The idea is also very straightforward, I will see. So here for each node, we are going to compute 2 pieces of information. One is the number of nodes in the tree, and the other is the tree sum. The tree sum means the sum of all the node values. So in between, we can check the condition. That is, we can compute the average, so that is tree sum divided by the number of nodes, and then retain the maximal average in the process. So this can be done by using a non-local variable if we want to write a nested function, or we can use attribute. So we'll make it clear later. So here, once we have the above interpretation, so the recursion relation is actually very intuitive or very simple. So here, let me change this f to be t. So let f compute given an argument as node, so it returns 2 pieces of information. One is an n nodes, and one is the tree sum. Then, if we want to compute the number of nodes for the current node, so we can first get the information for the left subtree, and then we get the information for the right subtree, then we add 1. In other words, the current tree has number of nodes equals the number of nodes in the left subtree and in the right subtree, and plus the node itself. That's why we have 3 terms in the right. So similarly, if we want to find the tree sum for the current node or tree, so we can get the tree sum for the node left and for the node right, and then we add the tree sum and then add this node value, right? So we get the recursion relation. That's it. So with that done, so actually we can write the code. because the logic is rather straightforward. So here I'm going to use a attribute. Let's call it result, because we want to maintain the maximal average. So we're going to initialize it like this. So negative infinity. So this is the smallest one. So then we are going to write the hyperfunction. So I'm going to call it f. So f, you pass a node. Let's call it root. Then it will compute or return two pieces of information. One is the number of nodes in the tree, and the other is the sum of the node values. So first, we are going to treat a special case, if not node. So this can be regarded as a base case for the recursion, so which is actually a stop condition. If the tree is null, so we are going to return 0 and 0. It means that so we have no nodes. And the second, sum equals 0, which is for a stopping condition, right? And next, we are going to consider the left and the right subtree, right? So left equals f root left and f root right. So notice that both L and R are tuples, right? So then we can get the number of nodes, and for this tree rooted at the root node. So that is 1 plus the left subtree nodes and plus the right subtree nodes. And the node value, so the tree sum, so it's also easy to compute. So it equals the node the root value, right, plus the left subtree sum plus the right subtree sum. So then so we can actually return this. So this is the number n nodes, number and the tree sum. Let me change this n to be s to make it suggestive. So another important thing we want to do is that during the recursion process, we want to update this result attributes. So that's where the code is more effective for the procedure. So here we want to do something like this. We compute the average. So the average is nothing but tree sum divided by n nodes. So in this case, because we know that n nodes is bounded below by 1, so this arithmetic expression is always valid. So then what we are going to do is to update this self-result attributes, right? So it's actually the maximal of its previous state and the current average, right? So this finishes the hyperfunction writing. So next what we are going to do is to call this function, right? So for this function call, actually I don't need the return specifically, so I just call and put it, pass it to the argument to be a root. Then once we call this function, this result attribute has been automatically updated. Then what we're going to do is to do the return. So we're going to return self result. So this actually forms the complete solution format based on the above idea. So now I guess we are ready to do a check. So first let's run the special case. So node, so here I'm going to write root. So now let's do this. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So I guess that's about it for a solution to this problem. And it's also it for the whole video due to the simplicity of the logic. So with that said, that's it. Thank you.